All right, welcome to Day 5, Lesson 4. We are talking today about trigonometric ratios. That's a very tricky word to say, I get it. Trigonometric ratios. This is our intro to trig, or trigonometry. Okay, that's why we get the word trigonometric for these ratios. Ratio, remember, is a fraction comparing two things. So the reason we have this idea, this concept, goes back to right triangles, which is most of what this unit has been over. We are talking today about the ratios of any two sides of any right triangle at a given time. Okay? So there's some terminology we need to understand. The first is what a reference angle is. So you need to understand that this is what a reference angle is. It's the angle that helps us determine which two sides are being related. And basically, these words that relate the sides as opposite leg, adjacent leg, or hypotenuse are all going to depend on which angle we are identifying as our reference angle. Okay, so here I've given you a diagram where I've labeled the three angles of the triangle, A, B, and C. C is the right angle. We will not use C as a reference angle. The reference angle, for our purposes today, are always going to be the acute angles, either A or B. Because the side that is opposite angle A is actually adjacent to angle B. Now, again, the hypotenuse never changes depending on what your reference angle is. Hypotenuse is always across from the right angle, so that one is fixed. Okay? Side that is opposite the right angle. That's what the hypotenuse is. Okay? The opposite leg is the leg that is opposite the reference angle. Adjacent leg would be the leg that is part of the reference angle, meaning next to. So if I was talking about reference angle A, side B here, the side labeled B, would be the adjacent leg. Okay? So we have to understand those terms to be able to talk about trigonometric ratios. If at any point you need to pause the video to make sure you have this copied down, please do so. Otherwise, I'm going to keep moving right along. So we have three trig ratios, or three trigonometric ratios that we're going to talk about. And that is sine, cosine, and tangent. Okay? Sine, cosine, and tangent. And we abbreviate these with the first three letters of each of these words. SIN is our abbreviation for sine. COS is the abbreviation for cosine. And TAN is the abbreviation for tangent. All right. These are ratios. Okay? That means it will be a fraction with one side over another side. Okay? The sine ratio, the specific sine ratio, is always the ratio of the opposite leg over the hypotenuse. Okay? The cosine ratio is always the adjacent leg over the hypotenuse. And the tangent ratio is always a comparison of the two legs. And it is also, or always, opposite leg over adjacent leg. So we're going to compare those. So our examples from the diagram above, okay, you can still kind of see that. Okay, if I wanted to use A as my reference angle, all right, the sine ratio of angle A, we write it sine A, or S-I-N-A, is equal to the opposite leg, which would be lowercase a this time, over the hypotenuse C. The cosine ratio of angle A is the adjacent leg to angle A, right here, side B, over the hypotenuse C. And the tangent ratio of angle A would be the opposite leg over the adjacent leg, A over B. And obviously the point of this is using real numbers to help us solve problems using right triangles. And this is going to lead into a lot of different ideas about right triangles and how we can solve for different sides and angles. Okay? Now, remember, angles, your reference angles have specific measures usually, and we're going to use those, and we can use those in our calculator. I'll show you how to do that as well. But you need to be able to quickly remember what sine, cosine, and tangent, which ratios those are. And so there is a nice acronym that helps us remember that. Okay? SOH, we pronounce so. CAH, we pronounce ka. And then TOA, we pronounce toa. Sohcahtoa. Okay? And they stand for these ratios. The sine ratio is opposite leg over hypotenuse. The cosine ratio is adjacent over hypotenuse. And the tangent ratio is opposite over adjacent. Okay? And so Sohcahtoa helps us remember those ratios. Okay, so let's try some examples using Sohcahtoa. Okay, I'm going to turn the page so we can get to some examples here. Now, as I've drawn these examples out, as I'm going through each one, make sure you pause the video to give yourself time to actually copy this down correctly. And I'm using line paper just like you are, so kind of make sure yours looks about the same that mine does. Okay, so in our first example, I'm just giving you a triangle where I've given you all three sides, and we're going to write the ratios once using A as our reference angle, then again as B being our reference angle. Okay, and I'm going to remind you of Sohcahtoa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And so for these problems, we are going to get fractions as our answers, and that's it. That's all we're going to do is write what the fraction is, making sure we simplify it if we need to. But we shouldn't need to because I've chosen numbers that won't simplify. Okay, so the sine ratio for angle A, we're going to look at angle A as our reference angle. Sine ratio would be opposite leg over hypotenuse. Well, the side that is opposite angle A is 3. And the hypotenuse is 5. So 3/5 is our sine ratio. Cosine of angle A would be the adjacent leg. Part of angle A is the side length 4 over the hypotenuse 5. And then the tangent ratio for angle A is opposite over adjacent, so 3/4. Okay, for the sine, cosine, and tangent ratios for the reference angle B, okay, we're going to switch opposite and adjacent because now the side that is opposite angle B is 4 and the side adjacent to angle B is 3. So the sine ratio would be opposite 4 over hypotenuse 5. Cosine ratio of angle B would be adjacent 3 over hypotenuse 5. And tangent ratio would be opposite over adjacent. Well, this time opposite is 4, adjacent is 3. 4/3. So that's one way we can identify sine, cosine, and tangent if I'm given all three sides. But remember that angle measures, or angles have specific measures, and so our calculator has actually already got all possible ratios programmed in for specific angle measures. Now, because of our triangle similarity that we talked about last semester, these ratios are always going to be the same no matter how long the sides actually are, because angles of similar triangles are congruent. And so the sine ratio for a 73-degree angle is always going to simplify to the same thing no matter how big it is. So we can actually just use your calculator for these kinds of problems. Okay? So it might look like this. I'm going to show you how to find those buttons on my calculator, but when you get to class, we will need to look at the specific calculator you're using to make sure you know how to do that. Now, you always want to make sure that your calculator is set to degrees. So if you're putting things in your calculator along with me in the video and you're getting different answers, we need to change that setting. Then you'll need to come into class so I can show you how to do that. Okay? But right now, we're going to type in a sine ratio for a 73-degree angle like this. You'll see these three buttons on most scientific and graphing calculators: sine, cosine, and tangent. So I'm going to find the sine button, and then I'm going to type in the 73-degree angle that I need. 73. You can close your parentheses. I like to make sure I do that just so it looks better on the screen, but it should give you the same thing either way. Hit enter, and we get a fractional value written as a decimal. Okay, so what I want us to do is use 4 decimal places, 0.9563. Make sure we use the correct rounding rules. Since the number after 3 is 0, it stays a 3. And that is our sine ratio for a 73-degree angle. Then we're going to do cosine of a 12-degree angle. So I just type in cosine 12, hit enter, and it's 0.9781. Depending on the size of the angle, these ratios could range anywhere from closer to 0 or closer to 1. But the tangent ratio could be a lot of different things. Tangent ratios are the only ones that could end up being greater than 1, and we'll look at that reason behind that in class. But let's say we have the tangent of a 37-degree angle. Just hit the tan button, 37, hit enter. And once again, we get 0.753. The last number after our 5 here is another 5, so that actually rounds up. Okay? So that's how we find sine, cosine, and tangent ratios in the calculator. All right? But now we're going to use that to actually use some problem solving. We're going to find the requested value. In this case, it's a b. Notice I'm given an angle measure, and I'm given a side length. So in order to do this, you need to make sure you follow these steps. We are first going to set up the correct ratio. The angle measure that is given to you is your reference angle. What I want to make sure I do now is label the two sides I'm using, only these two, as either opposite, adjacent, or hypotenuse. So this leg here is a leg adjacent to this reference angle, so that's my A for adjacent. And this side I'm looking for, this B, use capital letters, sorry. This side B is across from the right angle, so that's actually the hypotenuse. So I'm using adjacent to find hypotenuse. So I'm going to look at Sohcahtoa and figure out which of these three has adjacent and hypotenuse. That's Ka. The C in Ka stands for cosine. That tells me I'm going to use my cosine ratio. So I have to use cosine. The cosine of a 52-degree angle is always adjacent over hypotenuse. So in this case, the adjacent leg is 12. The hypotenuse is B. Now, to solve this problem, I want to think of these as proportions. I almost always treat these as proportions, especially when my variable's in the bottom of a fraction. So to turn this into a proportion, I'm going to put my cosine ratio over 1. You should recognize that now I have a situation where I can take the cross product. So I'm going to cross multiply. 1 times 12 is 12. And then b times cosine of 52. I'm not doing b times 52. I'm doing b times this value of cosine of 52. So I'm going to do b cosine of 52 and write it like that. The idea is to get b all by itself. So I'm going to divide both sides now by this cosine of 52 to cancel that out. The whole reason I do this on paper is so I know how to enter it in my calculator. Now I'm going to do 12 divided by cosine of 52 in my calculator, and I should get this. B ends up being about 19.5. You can see how I entered it in the calculator. 12 divided by cosine of 52. We will actually finish this example in class.